Welcome to day 23 of calculus. Today we will continue our exploration of the second derivative. In this first problem we are given a derivative, f prime. We are given a derivative and it's stated that the derivative is x squared plus x minus 6. It's the derivative of some function. Find the x coordinate of each maximum and minimum value of the function. So we're finding the maximum not of the derivative, of the function. So we're given the derivative and we want to find the x coordinate of each maximum and minimum. So the key thing to remember here is for a maximum happens when a function changes from increasing to decreasing. A maximum occurs when the function changes from increasing to decreasing. So this is a max. And a minimum occurs when the opposite occurs, which is when a function goes from decreasing to increasing. So the minimum is happening right there because the function is going from, decreasing to increasing. And the thing is, a derivative, as stated here, can tell us a lot about where a function is increasing and decreasing. So we want to know effectively where is the derivative positive and where is it negative, because a function is increasing when the derivative is positive. It's increasing when the derivative is positive. So we're looking for, that's when the derivative is positive. So it's increasing when f prime is greater than 0, which is also happening here. F prime of x is greater than 0. And it's decreasing when the derivative f prime is less than 0. So this question entirely comes down to asking us where is the derivative positive and where is it negative, and then find out where it changes from positive to negative or negative to positive. So the way we do that is we set the derivative equal to 0. If we find out where it's equal to 0, we can figure out where it's not equal to 0. This one's nice because it factors quote unquote nicely. X plus 3 times x minus 2 equals 0, and you can check that. So what does this mean? X equals negative 3 or x equals 2. That means the derivative is 0 at those values. So we know that at x equals negative 3 and at x equals 2, these are the x values, f prime of x is equal to 0 in each of these cases. So we'd like to know between negative 3 and 2, so in this region, and also from here to here and from here to here, is the derivative positive or negative? Is the derivative positive or negative? So we want to know, let's do the central region right here. Let's do this central region right here from negative 3 to 2. All we need to do is pick one number between negative 3 and 2. And a great number to check would be 0. If you can test 0, test 0. So plug 0 into the original equation here. If we plug 0 into the original equation, 0 squared plus 0 minus 6 is equal to negative 6. So this whole area has to be negative. Meaning, what does this tell us? F prime of x is less than 0 when x is between 2 and negative 3. But we have two more places to check. Let's check this one right here, to the right of 2, to the right of 2. So what's the number to the right of 2? Let's say 3. Let's plug in 3. So if we plug in 3, we get 3 squared plus 3. Again, we're plugging 3 into this, the derivative, minus 6. So that's 9 plus 3 minus 6 is 12 minus 6 is 6. That's positive. So we know to the right of 2, the derivative is positive. What about to the left here, the region to the left? Right here, region to the left of negative 3. So let's plug in, say, negative 4. So that's going to be negative 4 squared. Remember, we're plugging in negative 4 here, parentheses around the negative 4, plus negative 4 minus 6. And that's going to be equal to 16 minus 4 minus 6, and that's equal to 6. So right here, we know it's also going to be positive. So what does this tell us? It tells us the derivative is greater than 0 when, well, two places, when x is less than negative 3 and when x is greater than 2. So what's going on here? Let's draw this again. So we now know the derivative at negative 3 is 0, and we know at 2 it's 0. And we know that the derivative is negative between it, positive here and positive there. That means it's going increasing to decreasing to increasing. So increasing to decreasing, what is that again? Increasing to decreasing means it's a max. Decreasing to increasing means it's a minimum. So we now know that there's a max when x is equal to negative 3, and there's a minimum when x is equal to 2. So we came to these conclusions using the first derivative. Well, the second derivative can also tell us if it's a max or min. because it's a max when the derivative is 0 and if it's concave down. So the derivative is 0, f prime of x is 0 right there, horizontal tangent. And it's a maximum, it's a minimum there if it's concave up. And we know concave down is when the second derivative is less than 0, and it's concave up when the second derivative is greater than 0. So we figured out, it told us that the function itself, the derivative is this, x squared plus x minus 6. X squared plus x minus 6. What's the second derivative going to be? Well, that's going to be 2x plus 1. So we said, based on our sign diagram here, where we went from increasing to decreasing to increasing, the max was when x was negative 3. So let's do f double prime of negative 3. That's going to be 2 times negative 3 plus 1. So that's negative 6 plus 1 is negative 5. Well, negative 5 is less than 0, so f of x is concave, or COC, concave, I'll do CC, concave down when x is equal to negative 3. And that should be the case because we thought there was a maximum here. So it should be concave down. So that verifies that it's a max there. What about here? At the next one we said that there's a minimum at x is equal to 2. Well, we take 2 and we plug it into the second derivative, and we end up with f double prime of 2 is equal to 2 times 2 plus 1, which is 5, which is greater than 0. So f of x is concave up at x is equal to 2, which means it has to be a minimum. So you have this sign diagram, and this sign diagram alone can tell you if it's a max or min. But another way to tell it is the derivative 0, which we know it is because we did this factoring right here. We knew the derivative was 0 at negative 3 and 2. And we also know that the second derivatives are the right sign. It's negative, so it's concave down. And we knew it was positive here, so it's concave up. So for part B, it says, find the x-coordinate of any points of inflection. Points of inflection. A point of inflection is when it changes, a place where the concavity changes. Changes concavity. Changes concavity. This is important. So let's find the second derivative, and that's going to be 2x plus 1. Because you do the derivative of 2x, of x squared, and you get 2x, and the derivative of x is just 1. The derivative of negative 6 is just a constant. So the question is, where does this change sign? Where does that change sign? Well, similar to what we did before, we set 2x plus 1 equal to 0. So 2x is equal to negative 1. So x is equal to negative 1/2. This tells us that at x is equal to negative 1/2, the second derivative is equal to 0. So we want to know, what about over here? What about over here? Well, what's to the left of negative 1/2? Well, you just test one number, say negative 1. Plug negative 1 into here. So f double prime of negative 1 is equal to 2 times negative 1 plus 1. So that's negative 2 plus 1 is negative 1. So that means that this whole side right here is going to, if that's negative, the whole side has to be negative. So it's minus there. What's to the right of negative 1/2? Well, let's plug in 0. That's to the right of negative 1/2. So f double prime of 0 is equal to 2 times 0 plus 1 is equal to 1, which is greater than 0. So this means this side is going to be positive. So what happens? What does this tell us? This tells us that the second derivative changes from negative to positive around x equals a negative 1/2. And remember, negative second derivative means concave down, and positive second derivative means concave up. Overall, what this means is, from here to here, where x is negative 1/2, it's going to be concave down, and then when it crosses negative 1/2, it's going to be concave up. That's what it's telling you. And we know that the maximum occurs at x equals negative 3, and the minimum occurs at x equals 2. So this matches what we've done before. Just to reiterate, when you do these sign diagrams, once you know where the zeros happen, you only need to test one number on in each place, one number. So because when we plugged in negative 1, this came out to be negative, the whole side is negative. When we plugged in 0 and this came out to be positive, this whole area is positive. So in this question, we start with f of x. We're starting with the function. Find all maxes and minimums. So we need to know where this derivative changes from positive to negative. So we're not given the derivative, so we need to actually find the derivative. So the derivative of this, we can just use our shortcut because it's a polynomial, will be 3x squared minus 4x minus 4. We want to know where that changes from positive to negative, so we set it equal to 0. We set it equal to 0 to know where it equals 0 so we can find out all the other places if it's positive or negative. So now you need to remember how to factor this, and this will factor quote-unquote nicely to 3x plus 2 times x minus 2. So this tells us that 3x plus 2 equals 0, or x minus 2 is 0, so x will be negative 2 over 3, or x is equal to 2. So we could make a sign diagram right now, but we could also now check the concavity. So we know that at these points the derivative is 0, but let's check the concavity at those x values. To do that, we need to know the second derivative. If that's the first derivative, the second derivative, because it's still a polynomial, we can use the shortcut as 6x minus 4. So now we need to take these two values and plug them in. If you plug in negative 2/3, you end up with negative 4 minus 4 is negative 8. So what does that tell us? It tells us that the derivative is 0. So f prime of negative 2/3 is 0, and f double prime of negative 2/3 is negative 8, which is less than 0. A negative negative second derivative means concave down. So if the derivative is 0 and it's concave down, derivative is 0 and concave down, it means you have a point that looks like this. The derivative is 0 and it's concave down. So this means we have a max. We have a max at negative 2/3. We have a max at negative 2/3. So there's a max going on there because it's concave down and the derivative is 0 there. Now we do f double prime at our other x value, which was, what was it, 2? So we do f double prime of 2. It's going to be 6 times 2 minus 4. Remember, this is our second derivative right there. So when we plug that in, we end up with 12 minus 4 is 8. So what does this tell us? It tells us now, we know before that f prime of 2 is 0, and f double prime of 2 is 8, which is greater than 0, which means the second derivative is positive, so it's concave up. So concave up and the derivative is 0. Derivative is 0 and it's concave up means that x equals 2 is a location of a minimum because the derivative is 0 and it's concave up. Keep in mind we also could have done this with a sign diagram because we know that we have negative 2/3 and we have 2. So we have x and f prime of x. We know it's 0 in both of these cases. So we need to know is it positive or negative there? Is the derivative positive or negative there? And is the derivative positive or negative here? And what about right here? So you could do it this way. It takes a little bit more time and sometimes it's useful to do it this way. Let's try it. So what's between negative 2/3 and 2? Well, 0 is in between there, and this is the derivative. If we plug in 0 into that, we just get negative 4. So this whole area is negative. Now, this area, the blue goes all the way to the right and the green goes all the way to the left. So you could plug in a huge number over here, like a billion. Plug in a billion into this. You get 3 times a billion squared minus 4 billion. It's definitely going to be positive. And over here, if you plug in negative a billion, well, negative a billion squared is still positive. So you end up with positive over here. So what's going on? The derivative is increasing, and then it's decreasing, and then it's increasing. Remember, increasing to decreasing is a max, and decreasing to increasing is a min. And that matches what we came up with right here. We came up with this was a max, and this one was the x value of a minimum. So for points of inflection, remember this is a change in concavity, so change in the sign of the second derivative. So the second derivative needs to change from positive to negative or from negative to positive. This was our first derivative. F prime of x was 3x squared minus 4x minus 4. So for points of inflection, we need to find the second derivative. So that's going to be 6x minus 4. We already used that over here to check it, so it does the same. So we need to ask ourselves, where does this change from positive to negative or negative to positive? So we set up where does it equal 0. So that's 6x equals 4. So that's x equals 4 over 6, which is positive 2/3. So then we make a second derivative sign diagram. So this is x and f double prime of x. We know that when x is 2/3, the second derivative is 0. So what about when you're to the right of 2/3? Well, what's immediately to the right of 2/3? Well, you can plug in a huge number if we wanted to, or just plug in, I don't know, let's say 10. Plug in 10 into this. Is it going to be positive or negative? Well, 16 minus 4 is positive. What about to the left? What's to the left of 2/3? Well, how about 0? Plug in 0 into this, you get negative 4. So the second derivative changes from negative to positive when x is equal to 2/3. So when it says all points of inflection, we need an x and a y value. So what do we have here? We know it's going to be 2/3. We need to know what the y value is. To get the y value, we need to use the original equation. Here's the original equation. You would plug in 2/3 into there to get the actual point. And at this point, I remembered this one also asks for points. So this is just the x value. We would need to plug in negative 2/3 into here to get the y value, and negative 2/3 into, 2 into the original function to get the y value. So when it asks for points, you need x and y. So in terms of these points, when x is negative 2/3, y is 9.481. And when x is 2, that comes out to be 0, which is totally possible. And down here, when you plug in 2/3 into the function, you end up with 4.747. So up until that point, you didn't really need a calculator.